Section 10.6, Angle Relationships. The tangent chord theorem. If a tangent and a chord intersect on a circle, then the measures of the angles formed are half of the intercepted arcs. So the measure of angle 1 is going to equal half of the measure of arc AB. The measure of angle 2 is going to equal half of the measure of arc BCA. Since the angles formed, the vertex of the angles formed lies on the circle. It's the exact same formula as an inscribed angle, except now with a tangent and a chord, since the tangent is only intersecting the circle at one point. We have basically two inscribed angles formed. We've got angle 1 and angle 2, so they each are half of their intercepted arcs. The other thing we can notice about this is the two arcs formed make up the whole circle. So in total, the two arcs need to add up to 360 degrees because it's a circle. We can use this to find arcs or angles. Here we're asked to find arc STR. We know the measure of the inscribed angle is half of the measure of the arc, or we can go the other way with that. The arc is going to be twice as big as the angle, so we double our angle. 102 times 2 is going to be 204 for the measure of our arc. Here we're asked to find the measure of angle CBD. To do that, we need to find x first, so we know 3x. The angle there is going to equal half of its intercepted arc. So 3x is going to equal half of 4x plus 50. We distribute that through. 3x is going to equal 2x plus 25. Subtract off that 2x, x is going to equal 25. If we multiply that then by 3 to find our angle, we're going to get that the measure of angle CBD is going to be 75 degrees. Find the measure of angle FGI. We know the intercepted arc is 225, and we know angles are going to be half of their intercepted arcs. So FGI is going to be half of 225, so that's going to be 112.5, which is letter C. Find the measure of angle UVW. We want UVW, which is our red arc. We know that the tangent in the chord is going to make a linear pair, so the other angle from that 99 is going to equal 81. So the arc we're looking for is going to be 2 times 81, which is going to be our 162. The other way to find that would be to take the intercepted arc of the angle that they give us. They gave us 99. We could find that arc in green there is going to be 198. The rest of the circle is going to be 360 minus that 198. So then we would take 360 minus 198 to get 162 still. Either way, our answer is going to be C, 162. The chord intersection theorems. If two chords intersect in the interior of a circle, then the measure of each angle is half the sum of the intercepted arcs and its vertical angle. So the measure of angle 1 is going to equal 1/2 of the measure of arc CD plus the measure of arc AB. If we look at 1, angle 1 intercepts CD. The vertical angle from 1 intercepts arc AB. So we add those two arcs together. Take half of that, and that's going to equal each one of those angles. They're going to equal exactly the same thing since they're vertical angles. Same thing with the measure of angle 2 here. The intercepted arcs from 2 are going to be CB, and its vertical angle intercepts the arc AD. We add those two arcs together, multiply by half, and that's going to be the angle 2 there. The one thing we can notice about the two blue arcs, the two red arcs, the sum of those needs to add up to 360 because it covers the whole circle. So if we know the two blue arcs, we can find the sum of the red arcs without knowing each of the individual arcs themselves. So here we can use that to find x. We know the measure of angle x is going to equal half of the sums of the two arcs. X intercepts arc BC, which is 120 degrees, and its vertical angle intercepts arc AD, which is 40 degrees. So 120 plus 40 is going to be 160. We take half of that to find the angle. Half of 160 is going to be 80. Again, using the chord intersection theorem, we're given that our angle is 50 degrees, the arc it intercepts is x, and the arc its vertical angle intercepts is 84. So 50 is going to equal 1/2 of 84 plus x. We can multiply both sides then by 2 to get rid of the half, so 100 is going to equal 84 plus x. Subtract off the 84, x is going to equal 16 degrees. Here we're asked to find x. To find x, we need to know the sum of the arc it intercepts and the arc that its vertical angle intercepts. So we need to know the sum of AB and CD. But we know the whole circle needs to be 360. So if we subtract off the other two parts from 360, that's going to give us the sum of AB and CD. So we know arc AB plus CD is going to equal 360 minus the rest of the circle, so minus 164, which would be our 92 and 72 added together. So we know the sum of those two arcs is going to equal 196 degrees. And we know our angle is going to equal half of the sums of our arcs. So x is going to equal half of 196, which is going to be 98, which is letter C. Here, same thing. We want to find half of the sum of the intercepted arcs because we're looking for x, but we know the other two arcs, so we have to subtract those from 360 to get the sum of our arcs, and then we multiply that by 1/2, so we're going to have half of 190, which is going to equal 95, which is letter B. Again, finding x, we're told that the measure of our interior angle there is 67 degrees, so we know the measure of our angle is 67 degrees. That's going to equal 1/2 of the sum of the two intercepted arcs, which is going to be x plus 30. So we can either distribute the 1/2, or instead of dealing with half of a variable, we multiply both sides by 2. So 134 is going to equal x plus 30. Subtract off that 30. 104 is going to equal x, which would be letter D. The secant tangent intersection theorems. If a tangent and a secant, two tangents or two secants intersect in the exterior of a circle, then the measure of each angle is 1/2 the difference of the measures of the intercepted arcs. So angle 1 here is going to equal half of arc BC minus arc AC. So the two intercepted arcs is going to be BC and AC. And since we're on our angle is on the exterior of the circle, we take the difference of those two arcs. So the bigger one minus the smaller one is going to equal the measure of our angle. The way I remember this equation is that if our angle is formed outside of the circle, it's different. If you are outside of the circle, maybe you're different, or if you're outside of a circle, sometimes it's looked as a negative thing. So that would be our subtraction. That would be the difference here. When the intersection happens inside of the circle, it's positive to be a part of something, so we add the two intercepted arcs. That's just my way of remembering. Continuing with the secant tangent intersection theorems, when we have a tangent to a tangent, it's the exact same formula. The measure of our angle is going to equal half of the difference between the measure of the intercepted arcs. With a tangent to a tangent, the two arcs are going to end up making up the whole circle. The bigger arc is going to be PQR. We go around the two intersection points the long way, and we're going to subtract off the short piece, which would be PR. Again, when we have a secant and a secant, same formula. Our angle outside of the circle is going to equal half of the difference of the two arcs created. So we take the far arc, which is going to be XY, and we subtract off the smaller intercepted arc, which would be WZ. The difference with the secant to secant is we have two intercepted arcs that don't make up necessarily a majority of the circle. They're usually a little smaller. With the tangent to tangent, the two arcs are the whole circle. So that theorem again, if two secants, a secant and a tangent, or two tangents intersect the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Alright, so let's use that here. We're given the angle created by a tangent and a secant is 72 degrees. The intercepted arcs are 200 and x, so we know 72 is going to equal 200 minus x. We can solve that for x. After we multiply both sides by 2, 144 is going to equal 200 minus x. So negative 56 is going to equal the opposite of x, so x is going to equal a positive 56. Here we've got two tangents intersecting, so we know x is going to equal half of the measure of the intercepted arcs. They only give us one intercepted arc, that's 96 from our two intersection points is 96 degrees, but we know the whole circle is 360. So the circle is, the other part of the circle is going to be 360 minus our 96. 360 minus 96 is going to give us 264, excuse me, 264 degrees here. So we plug that into our formula. We know x is going to equal half of 264 minus 196, so x equals half of 168. So our angle x is going to equal 84 degrees. Here we are asked to find the measure of arc QS. We have two secants intersecting outside of the circle. So we know the angle, which they give us is 56 degrees, is going to equal half of the difference of the intercepted arc. So we go to the far arc, that's 135, minus, because it's difference, of QS, which we don't know, so we'll call it x, so minus x. To get rid of that half, we'll multiply both sides by 2, so 112 is going to equal 135 minus x. Subtracting off that 135, negative 23 is going to equal the opposite of x, so then we know x is going to equal a positive 23, which would be answer A. Here we're asked to find the measure of arc FIH. We know arc FH is 130. We have two tangents intersecting outside of the circle. So there's a couple different ways we could do this. We could plug it all into our formula. We know our angle 50 is going to equal half of the difference of the arcs. It's going to equal half of 130, half of x minus 130. And we can solve this for x, or we can just be intelligent math students. We know when two tangents intersect, the two arcs that are intercepted are going to be the whole circle, which would be 360 degrees. So we know FIH is going to be 360 minus arc FH, so 360 minus 130. So we know that's going to turn out to be D, 230 degrees. And we can double check that right away. We multiply both sides by 2. 100 is going to equal x minus 130. We add the 130 to both sides. 230 is going to equal x. So our answer is letter D. And this ends lecture 10.6.